Okay. All right. So Oscar is getting ready, going to invest $79,000 and leave into account. So these aren't just necessarily for banks. They're also for like some people invest. Like when you work, when you eventually get to your like your full-time job, if you go to college or if you don't go to college, whatever your options are, and then you eventually go to work, right? Eventually what you'll do is you want to save for retirement, right? Because once you stop working, no one's going to pay you because you're not working, right? So some so a lot of people do is they save, they put a bunch of money away, and then they don't touch it until they retire. And then when they retire, it's become this big sum of money, and then they live off of that. That's what they do. Okay, that's what a lot of people do. Um, Sounds like that's kind of like what these problems are kind of too. Not necessarily, just like a bank account, but it could be like mutual funds or investments, things like that that you can do to that are available too. Okay, so Oscar is going to have $79,000. He's going to deposit that, or he's going to invest that, and leave it into an account for 9 years. So he's not going to touch it. Not going to pull anything out. Not going to put anything in. He's going to leave it in there for 9 years. Assuming that the interest is compounded monthly, what interest rate to the nearest tenth of a percent would be required in order for Oscar to end up with $96,000? Okay. All right. So let's go through these. 79,000. What letter would I assign 79,000 to? So it's either A or P. It's what he's starting out with, principal, right? So that's P. Good. He's going to leave it in there for 9 years, so that's T. Compounded monthly, his interest. So they're going to put money, they're going to put interest into his account every month. So how many times is that in 1 year? 12. What interest rate? Well, there it's the question right there. What interest rate? So it sounds like R is going to be our question mark. And then the last thing, would be required in order for Oscar to end up with $96,000. So when he comes back in 2000, whatever it was, 9 years later, when he comes back, he wants 96,000 to be there instead of 79. So that's going to be our final amount, right? So which formula are we going to use? The first one from the front page or the second one? First one, yep, because n, we have a number for n, right? It's not compounded continuously. Okay, so let me rewrite that. And then I'm going to plug everything in. Okay, so A, we know A is $96,000. We know P is $79,000. 1 plus R, we don't know. So I'm just going to leave it as R. I'm not going to change it because I don't know what it is. That's what I'm trying to solve for. N is 12. And then over here I have N is 12 again times 9, right? Okay, so that's the formula. Now what we have to do is solve for R. That guy right there. Okay. All right, so the first thing I'm going to do is I'm going to multiply the powers just like we always did. So 12 times 9 is a whole number. What is 12 times 9? 108. 108. So I'm going to change that to 108. Okay. Okay, so now let's take a look at this. I want to get R by itself. Let me write this too. So this is going to take some thinking here. What do I do next? Yeah. Yeah, that's what I'm thinking too. Because over here, right? Yeah, I'm thinking I'm going to divide over here. I can't add up these two. I can't divide and add up like I usually do, right? Because R, I don't know what it is. So I can't do that. That's off limits, right? This power right here is a very, very big power. So that means there are 108 of these lined up. I don't want to have to multiply those out. That's going to be a lot of multiplication boxes. I don't want to do that right now. But what I look at is this 79 here, 79,000. It's 79,000 times this, right? It's 79,000 times that. So the opposite of 79,000 would be to divide by it. Divide both sides by 79,000. So on the right side, anything divided by itself just makes a giant 1. Okay, so that's no longer there. So I just have 1 plus r divided by n to the 108. Okay. Still trying to find r. On the left side, I have two big numbers divided by themselves. If you were to use your calculator to divide those two numbers, you're going to get a decimal that is a long decimal. It's not a decimal that's a friendly decimal, right? It's going to be, watch. Let's see if I got my calculator here. Let's see. 96, what was it? $96,000 divided by $79,000. That bottom decimal, that's pretty long. And guess what? My calculator stopped there, but it doesn't stop. My calculator just stops there because that's as far as it goes. So I don't want to divide them like regular divide. So what I'm going to do is kind of reduce them. I'm going to reduce them. So how do I reduce them? Well, the first way to reduce them is you can divide them by a bunch of zeros. So if they have a bunch of zeros that line up, you can just divide them by all of those zeros. So those zeros aren't there anymore. So I have 96 over 79. If you were to divide 96 by 79, you would still get that same decimal that we had 15 seconds ago. Okay? We don't want to leave that. We don't want to round until the very end. We want to try not to have to round until the very end. Okay? Okay, so let's stay right there. All right. What do I do now? Because I want to get r by itself, right? I want to get rid of the parentheses. If I got rid of the parentheses, then I could solve for r. So what's one step that I could do that would get rid of the parentheses? So yeah, mess with this 108, right? What is that? That's a power, right? That's an exponent. How do I get rid of a power? What can I do to get rid of a power? We've done it before. What do I do to get rid of a power? Yeah, make it to a fraction, right? What is that called? The top is the power, the bottom is the what? The root, right? The root. The bottom and top is the power, the bottom is the root. So this is what I want to do. What power would I want up here so that I don't need parentheses anymore? What power would be perfect up here so that I don't have parentheses anymore? Think of any power, think of any parentheses. What power do you want out there? 1, yeah, we want 1. We want this power to be 1. So how can I make this power of 1 using, what number would have to be down here to make that a 1? The same power, right? So really what I have to do is I have to take the root, use a different color, here we go. But I have to take the 108th power, the 108th root. What does that mean? Well, on the inside here, right? On the inside, how many of these guys do I have lined up times each other? 108 of them, right? And what does this number out here mean? Of a kind, right? 108 of a kind. Well, how many groups of 108 do I have on the inside? One group. So I take out one of these guys. Okay. Now, whatever I do to one side, I got to do to the other. So I have to do the same thing to the other side, which is not so bad because my calculator will come in handy there. Okay. So if you go to Delta Math, So go over to Delta Math. I'll show you how to do that, to calculate that number. Oops, where is it? Here we go. Okay. So what I'm going to do is I'm going to hit this button Shift. If you hit the Shift button, you'll see this button right there. The N, the root with an N on it. That means I can change that number. If I choose the one with a 3, that means I have to use a 3. I don't want a 3. I want a 108. So I'm going to choose that number. I'm going to choose the one right there. So now it says, okay, which root do you want to run? 108. So I'm going to plug in 108. Then on the inside, I'm going to do my fraction. My fraction was 96 divided by 79. That's the number I want to write. Okay. 1.0018066262. I don't want to have to write the whole thing, so I'm just going to go 4 decimal places. 4 decimal places. So 0018. 1.0018. Okay. Okay. Now that I have a power of 1 up here, I don't need the parentheses anymore. That's what I wanted, right? So now what could I do to solve for R now? What could I do to solve? Let me keep extending my line here. Subtract 1 from both sides. Good. Subtract 1 whole. So I'm not going to subtract it from the 8 or the 1 in the back. I'm going to subtract it from the 1 in the front. So that just leaves change. Why did I write N? Why do I keep writing N? N is 12, right? Yeah, no, I should have wrote 12. Sorry. So now I have R divided by 12. How do I get R by itself? Well, it's being divided by 12 right now, right? So what's the opposite of divided by 12? Multiply by 12. Good. That side just makes an R. So now I'm going to go back to my calculator and I'm going to put 12 times 0.0018. Or if you still have that number, that long number, multiply that number times 12. Even better. My previous answer times 12. No, that's not what I wanted. That's not what I wanted. 12 times 0.0018. So I get this number here, right? 0.0216. Solve for R. But they wanted R as what? What did they say they want R as? A percent to the 10th. So the next thing I got to do is change it to a percent. So how do I change R to a percent? Multiply. Yeah, you can multiply that number by 100, or you can just move the decimal 2 places to the right. So it'll be 2.16%. Which number is in the 10th spot? 1. Yep, 1's in the 10th spot. So we look at 6. Does 6 say move up to 2 or stay at 1? Move up to 2, yep. Right? Like I get this question a lot. Mr. Flores, do you round up? So 89.5, 79.5, do you round up? Well, if it's 5 or higher, I do, right? If it's 4 or lower, I don't. It's the same thing. Okay? Rounding is the same thing. Okay? All right. So now what we're going to do is